Hey everyone! I hope you all are feeling great after finishing a Jan 25 Chemistry Unit 1 exam. Whether you think it went well or you are unsure about few things, you are not alone. Today we are going to go through the exam paper and break it all down together. We'll cover each section, discuss the tricky questions, and highlight some of the key topics that came up. If there were any moment in the exam where you were left scratching your head, don't worry, we'll explain everything step by step. So grab your notes and let's get started on reviewing the exam. You will feel much more confident about what's ahead and you will know exactly what to focus on for the future. Let's dive in. But before we start, today I'm just going to cover the part A of the exam paper. Do comment how you felt about this exam. Let's begin. So the first question says that what is the total number of atoms in 8.8 grams of carbon dioxide? So you want to know how many atoms are there. So we will just going to write the things which are given to us. So it says mass is given 8.8 grams. We know MR is also given, which is 44. We can find the moles. So if we calculate, the moles will be 0.2. Now we are going to just multiply the 0.2 with the Avogadro's number, which is 6.02 into 10 to the power 23, which is also given. You will get 1.204 into 10 to the power 23. Now it's again, I'm repeating, it says number of atoms. So in carbon dioxide, I'm having 1 carbon and 2 oxygen. So I have total 3 atoms. Clear? So I'm just going to multiply 3 into 1.24 into, sorry, my bad. So 3 into 1.204 into 10 to the power 23, and when I solve it, I will get 3.6 into 10 to the power 23. So now question 2 says how many moles of ions are there in this much solution of this much concentration of magnesium nitrate. So whatever is given we will just quickly write down. So volume is 40 centimeter cube. Concentration is 0.050 moles per decimeter cube. And with this I can easily get my moles. C into V, convert this into decimeter cube, which you will get in the final answer, which will be 0.002. So this is the number of moles. Now you are going to find how many moles of ions are there in this much ions. So let's check the ions. So in magnesium nitrate, MgNO3, how many ions are there? So Mg plus 2 and nitrate is 1. So total I have 3 ions. I'm just going to take this answer and multiply by 3. So when I see, I'm getting 0.006 moles, which is C. Let's have a look at question number 3, which is talking about the atomic mass unit measured in grams. Alright, so I can see that mass of water is given to us 2.9908. Okay. Then we also know that H2O contains 2 atoms of hydrogen and 1 atom of oxygen, and hydrogen's atomic mass is 1 and oxygen's atomic mass is 16. But I have 2 hydrogens, that's why I'm going to multiply with the 2. So I am having 2. It's nothing but just the what I say is the AR of hydrogen. So hydrogen's AR is 1. So 2 hydrogen are there. So 1 times 2 is 2 plus 16. So total water's AMU is 18. Now I'm just going to find the mass of 1 AMU, which is mass of H2O upon the total mu of the molecule. So I have with me 2.9908, which is given into 10 to the power 23 upon total mR of water molecule is 18. You solve this, you will get an answer of 1.6616 into 10 to the power minus 24. So your answer is D. Sorry, this was out of frame. Just have a look. Alright, question number 4 says, what's the relative molecular mass of this oxide? NXO4 is an oxide of nitrogen. The percentage by mass is 69.57. You have studied that percentage by mass is the AR upon MR into 100. Now, percentage is given to you. 69.57 is equal to AR of oxygen, because nitrogen I have no idea about it. It's not given. So oxygen I know it's 4 times 16 upon the total MR, which is nitrogen is 14 times X, because it's not given, plus 64 times 100. You rearrange the equation, you simplify it, you will get the value of X2. Now you're going to calculate the relative molecular mass of this oxide, which is nitrogen is 14 times X, the value of X is 2. I'm just substituting the value of X in place of X, plus 64. So I'll get an answer of 92. So my answer is B. Okay, question number 5 says 4 different solutions contain chloride ions. 3 of the solutions contain the same number of molecules of chloride ions, which which solution contains a different number? Okay, hydrochloric acid, iron chloride, magnesium chloride, and sodium chloride. You calculate the moles for each, but make sure you see that HCl, when dissociate, it breaks into H plus and Cl minus. On the other hand, FeCl3, when it dissociates, Fe plus 3 plus Cl minus. If I have to balance, I'll see that I have 3 chlorine here. 3 magnesium chloride, MgCl2, when it breaks, Mg plus 2 plus Cl minus, but I have 2. Yep. And sodium chloride, NaCl, when it splits, Na plus and Cl minus. Now, I'm going to find out the number of moles. Alright, so I'm going to use my calculator to calculate the number of moles. I will be converting the centimeter cubes into decimeter cube. So 15 divided by 1000 is 0.015 times 0.80. I get here 0.012 moles. Next, I'm going to check for B. So 10 divided by 1000 is 0.01 times 0.40, which is equal to 0.004, but I have 3 chloride ions, so I'll multiply by 3, I get 0.012. Let's check option C. 10 divided by 1000 is 0.01 times 0.90. I get 0.009, and I'm having 2 chloride ions times 2, which is 0.018. And the last option, 20 divided by 1000 is 0.02 times 0.60. I get here 0.012. So what I see here is I'm having the same number of moles of chloride ions for A, for B, and for D. So only option is C, which is different. So my answer is C. Now, question number 6 says a solution contains 95 ppm of a solute. What mass of solute is dissolved in 1 kg of the solution? So it's very simple. Just put the values in the formula. So parts per million is equal to solute upon solution times 10 to the power 6. I have the value here. 95 is equal to x upon 1000 grams into the power 6. You solve it, you will get the answer. So it will be, let me 0.095 grams. So my option is C. Question 7 says a sample of hydrated magnesium sulfate contains 43% by mass of water. What is the formula for this magnesium sulfate? Simple. I have with me 43% of water. Let's assume that 43% is the 43 grams of water. So I can easily get the mass of magnesium sulfate, which will be 57. Now I'm going to calculate the number of moles. So mole of water will be 43 upon 18, which is 2.39 approx. And moles of MgSO4, 57 upon 120.4, which is 0.47. Take the ratio and let's find out the answer. 2.39 upon 0.47. It's almost, it's 5. So my answer is B. There you go. So now they are asking about the atom's economy. So it's the mass of the desired product upon the sum of the molar mass of the product times 100. Find the MR of the ethanoic acid times 4. So ethanoic acid MR is 61 times 4, which is 244. And the MR of water is 18 times 2 is, okay, plus the MR of which is 244. So total will be 280. Now the desired is 244 upon 280 times 100. The answer will be 87.14, which is D. Question number 9 says the first 4 ionization energies of the element gallium, indium, germanium, and tin are shown. Which values are the first 4 ionization energies of gallium? Okay, if we have a look at gallium and indium, germanium and tin, gallium and indium, they both are in group 13, and germanium and tin, they both are in group 14. Germanium, if you see, the first ionization energy is higher than the gallium because the outer electron is in the 4p orbital. So more nuclear force of attraction. Now if you are looking at tin, again it's in group 14. The first ionization energy will be higher than gallium, but it will be lower than germanium. Tin is in the same group you have seen, but one period down. So the outer electron is further away from the nucleus, so more shielding, right? So in this way, I got the idea that group 14 elements, which is germanium and tin, they both will be having higher first ionization energy as compared to gallium. So now I can exclude these two options. Now I am left with A and B. Now I'm going to compare both of them, and you know both of them belong to group 13. Indium is just below gallium. So gallium and indium, they both are in group 13, and indium is below gallium, which reduces the attraction between the nucleus and the outer shell electrons. So the first ionization energy of indium will be less than gallium. So in this case, my answer will be option B, because indium's first ionization energy is less than gallium. So this is indium. So this is definitely gallium. So answer is B. Let's move on to the 10th question. The question number 10 is asking for sulfur is having high melting point than phosphorus. They both are non-metals. Sulfur is 16 and phosphorus is 15 electrons. Okay. Which is a possible reason for this? Sulfur molecule have a great permanent dipole than phosphorus molecule. Let's move on to the next option. Sulfur has strong covalent bond than phosphorus. It's not a diatomic. Sulfur has a giant covalent structure and phosphorus is simple. No. Sulfur molecules have more electrons than phosphorus molecule. This is the answer, because there's a concept of something called as London forces, which you are going to learn in unit 2. But you also know that more electrons mean more stronger bonds. More stronger bonds mean more energy to break, leading them to get higher melting point. So this is the correct answer. Let's talk about question 11. Now if you notice, they all are isoelectronic. They all are having the same electronic configuration. But if you notice, potassium ion is it lost one electron. So this gives me protons 19 and electrons 18. So if you see, it will experience strong nuclear forces of attraction, hence the size of the radius will be small. Let's have a look at argon. Argon, noble gas, is going to be neutral, it won't be losing or gaining, so protons and electrons, the numbers will be same. There won't be any effect on the size. Chloride ion is going to gain one electron. So chloride is having how many protons? 17. Electrons will be 18. So it is going to experience electron-electron repulsion. Size will be large. Okay, now let's talk about bromide. So if we see bromide ion, it again going to gain electrons. Oh, sorry, electron. My bad. So proton will be 35, electron will be 36. Again, it will be experiencing electron-electron repulsion, but the repulsion will be more than chloride ion. So size will be the largest. So the correct sequence is this, A. Your correct answer is A. Question number 12. Simple question. Which cation would be the most polarizing? It's just a straight answer. You know that the factors which affect polarization is the charge and the size of the cation. Smallest the size of the radius and highest the charge. So answer is A. Clear? This looks a strange question. Let's find out. So it says in the gas phase, PCl5 exists as molecules. They are trigonal pyramidal. Each chlorine atom can be replaced one at a time by the fluorine atom. The two axial chlorine atoms are replaced before the three equatorial atoms. Which of the following does not have permanent dipole? So they are talking about how you can, add fluorine to this structure, and the outcome should be like the molecule should not have the permanent dipole. So the axial positions are the more electrostatically repulsive. So the replacement of these atoms with fluorine will lead to the more stable structure. So the more stable structure, And also, to cancel out the dipole of fluorine atoms, they must be placed at opposite directions. So it's again axial. In opposite direction, the fluorine will cancel out each other, leading to no overall dipole moment in the molecule. And if you're talking about the equatorial, these chlorine molecules will not be having any significant contribution to the uh, dipole. So the correct answer will be BCl 3F2, which is B. Okay, so we have moved to the organic part, my favorite. It says which hazard symbol would be found on the bottle of hexane. It's obvious, flammable. What is the IUPAC name for the following hydrocarbon? Let's look for the longest straight chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's decane. A and D, A and C gets terminated. So we have B and D. We will start counting from the side which gives the side chain the lowest possible number. So 1, 2, 3, 4. So 3, 4 dimethyl decane. That's your answer. Alright, let's look at question number 16. It's saying which statement about the cracking of crude oil is true? Cracking of crude oil separates the mixture into pure? No. Separates the mixture into fractions? No. Separates saturated from unsaturated? No. Answer is D. Decrease the average number of carbon atoms. Clear. Now look at question number 17. It's saying bromine and bromine water can be used to test for the carbon-carbon double bond. When bromine water reacts with 2-methylbutene, there is one major product, which is the skeletal formula of the major product. So have a look. So this is butene. So methylpropute, pent. So C and D will not be there. So your answer will be either A or B. Now, bromine and bromine water, fine. So double bond is on the second, it's on second carbon, right? So double bonds is going to break. For example, if there's a double bond here, it will break, and there is option of hydroxide and bromine. So on one bond bromine will add, and on the other bond hydroxide will add. Now they both are same, but now we have to see who will get the preference first. So in this case, hydroxide always get the preference over bromide. So 1 2 1 2 3 4. So this will be your answer. All right. So question number 18 is asking which of these formulae are correct for the compound 1,4-diethyl cyclohexene. So 1, 4 double bond, 2 ethyl groups attached to hex. 1, 2, 3, 4, 5, 6 hexene. 1, 4. So formula is correct. Molecular formula, count the number of carbons and hydrogens. So if you count 1, 2, 3, 4, 5, 6, 7. All right. So there are 10 carbons, and in respect to that, if you count the hydrogens, you can count along with me, by the way. So 1, 2, 3. So it's correct. And let's have a look at this empirical formula, which is also correct. So the answer is C. Let's look at the 19th question. So question number 19 is asking for how many pi and sigma bonds. Okay. So it's clear. 1, 2, 3, 4. So there are 4 sigma bonds. So this means that C and D is not the right answers. So we are going to cut short them, and now we are going to choose the answer from either A or B. If you restructure it, I have done it beforehand, but if you want to restructure it, you will notice that there are 15 carbons. So if you count the number of hydrogen, it's coming 38. So answer is B. Okay, so this is the last question for section A, and it's the isomerism. Which structure is a Z isomer? So let's see. Uh, Based on the priority, um, the answer would be D, because look at the atomic number of this and this. So they both are more than the bottom ones, and they are on the same side. This gives you the answer, and that's it. So guys, we are done with the section A of this paper, and I will be back with the section B. If you like this video, please do subscribe and give me your feedbacks in the comment section. Tell me about the exam, the pattern, the questions, whatever you felt about this exam. Do let me know in the comments. Till then, see ya. Bye.